Good afternoon, Jan.
Michael, good afternoon.
How do you do, sir?
We made it just in time.
Just in time. Yep, I'm over here making sure that the demo's working. Say, oh, I hear the clock. It's chiming the hour.
Yeah, I didn't send you feedback on the book on chapter 4. The truth
Mm-hmm.
is, I let myself be carried away by the beauty of Oot
Yes, it
to
is.
realize.
It is actually pretty nice, isn't it?
Yeah, after your explanation last time, I started reading a little bit on internet.
Mm-hmm.
Uh, then got to YouTube, then got to plural site
Uh-huh.
to
Oh
discover
goodness.
that what I thought I understood, I didn't understand it at all.
Oh wow. Okay.
So
Well,
I'm
that's a
I'm
good learning
still
journey.
I'm still going through it, but at least I think I'm halfway through it now.
Okay. Yeah.
Uh, got this quite a good course from Scott Brady
Okay.
on Pearl site. Got a very nice YouTube video on this website Okta.
Right. Yes. Mm-hmm.
Um,
Yeah. Okta
I
is one of
heard.
the leading vendors in the OAuth
Mm,
space.
and
Um,
there was
I found that a lot of the best documentation is on the Auth0 um, documentation site. So Auth0 used to be a separate company. Okta has acquired them. Um,
mm,
yeah, Auth0 is one offering from them, and Okta is another.
yeah. And they even have an authDebugger.com website and an OEDC debugger, OpenID debugger.com,
Mm-hmm.
which allows you to play a little bit with it. Uh, Much the same as the Google OAuth Playground.
Okay. Yeah, I haven't played with the
Um,
Google Auth Playground.
yeah.
Yeah, I usually go back to the Auth0 stuff because they did such a great job of
Mm,
putting the JWT debugger. I use that all the time. But
okay.
yeah, that's yeah, that's a
But it's
good set of sources.
but it's
Mm-hmm.
quite surprising all the things that are behind it and the reasoning.
Mm-hmm.
Um, So I got completely carried away from historical modeling, um,
That
which on one hand
happens.
is a pity, but on the other hand, I find it always surprising that OAuth is used so much in everyday's life.
Mm-hmm.
Yeah, if you go to Facebook, if you go to whatever site you want to log in with your Google account, but what happens behind the scenes is always a mystery.
Mm.
Um, it was even for me, more or less. And I will always worry, okay, if you see log in with Google in your URL, you can see whether it's really Google and whether it's secure.
Yeah.
But I'm wondering if you would just show, you make your own website, you show login with Google, um, and it's not from Google.
Yeah.
I think a lot of people would enter their Google credentials.
Yeah. Yeah. I think so. And that's actually been a big problem in mobile, because when
Mm,
you have the embedded mobile browser and you redirect over to Google to log in, you don't even see the URL. You just see
mm,
the login page. So how do you
yeah,
know that mobile application really is going to Google?
yeah,
Some of the things that
and,
help in that area is that the browser um, can store things for you. So you've got cookies, you've got password storage, and so
mm,
if it truly is Google that you landed on, then the browser will either you know, log you in automatically because you already have a cookie you just logged in earlier that day,
mm.
or it'll automatically fill in your password if you've got password uh, saving turned on. Um,
Yeah,
so
but
that helps a little bit.
then you're giving your password again to the browser.
Yeah, yeah,
Yeah.
you're giving it to the browser vendor or the OS vendor.
Mm.
Um, so
I
so yeah,
never
there's
looked into that.
some trust you have to give up.
Saving the password in the browser is it really secure or is it not?
It is. Yeah. So it's encrypted using a machine key.
Mm,
So so that machine key is protected by the operating system, um, and so you can't convince the operating system to give up the machine key. Um, but if you were able to access the encrypted passwords and then move them to another machine, you wouldn't be able to decrypt them because it's got a different key.
mm,
Um,
yeah.
so that's the
Mm,
mechanism that they're using.
yeah. Now maybe their multi-factor authentication of authorization might help.
Mm-hmm.
Um,
Yeah.
then if you log into and it's not Google, yeah, no,
Mm-hmm. Yeah.
no, you give your password, you give your login,
Uh-huh.
uh,
And
your
then they
portable is
spoof a
not.
login against actual Google, and then actual
Yeah,
Google sends you the MFA request, and you think that it's
yeah,
legit. Okay, answer
yeah.
that.
So it's not helping. Uh,
Yep, yep,
it's
that is a problem.
complicated.
Yep, yeah. Well, we're constantly working on trying to make it better.
Yeah.
And OAuth 2 was a pretty good step in that direction, I think, and um, it's survived in its current form more or less for a while. They've added new flows to it.
Mhm.
Um, yeah, I remember when it first started, there were like 5 different flows that you had to memorize, and then they say, oh wait, no, we found a vulnerability in this one, um,
Mm.
and now it's really just down to 2, and it's authentication code and then authentication code with Pixie. Um, use one of those 2, and forget implicit flow. I don't remember the names of the others, but yeah, don't worry
Oh,
about
yeah,
anything but those
I
2.
remember, oh, but that's 10 years ago probably, reading
Yeah.
a blog about one of the original inventors of OAuth,
Yes.
who was absolutely not didn't agree with OAuth 2, and it
Yep.
was like a big fight. Um,
Yep.
yeah, and
Yep. And the big concern there is that clients were responsible for part of the encryption with the original OAuth, and OAuth 2 um, introduced some flows that didn't require the client to participate in encryption, and so that you know that opens or yeah, I would say that having the client participate in encryption means that you can have a secret on the client that never leaves the client. Um, and so because of that, you can build uh, some really secure flows. Um, but yeah, the OAuth uh, community wanted low power devices to be able to participate and
mm,
log in. So it's like, okay, we're not going to be running RSA on the client, so let's come up with something else.
mm,
So yeah, at this point, the only thing that the client has to be able to do is a SHA hash. Um, yeah,
or
it doesn't
Pixie.
have to do. Yeah, even Pixie is based on SHA. That's the only encryption that it
Mm,
needs to do. Um, yeah, so HMAC SHA is how we sign a token, and so a client can validate HMAC SHA just with the hash algorithms. Um, yeah, you can also sign a token using RSA, and in
mm,
fact, the Jinaga Replicator uses an RSA signature, um, and then a low-powered client can just choose to trust the token, or use the token to call an API and let the server validate it. Um, uh, but yeah, nowadays you can
mm,
actually run RSA in JavaScript in the browser if you choose to.
mm.
It's of course a little bit power hungry, but that's the price you
Okay.
pay.
Yeah, it's wonderful.
Yeah, good stuff. Well, um, I've been advancing the state of feeds over the week. So yeah, I have some uh, something to show on real time push of information to the clients.
Okay, that's
So
great.
yeah, let's see if I can get a demo working. I've managed to see part of this work on this machine, and I've been doing most of this work on my my Mac. So
New Mac is well used then.
yes, yes indeed. Yep, you got Docker set up on it. I've got a couple of different Postgres database containers, so I can switch between using a single Jinaga database versus the multi-tenant database that powers the Replicator as a service. So yeah, testing out all kinds of things. So let's start here in Replicator as a service. I've created a replicator, published it, so this endpoint is available, but no security. So I have not added authentication, authorization, or distribution. It's just wide open. So, by the way, this is the order in which you would want to do things if you are playing around with stuff. But if you are actually releasing to production, set all those things up before you hit the publish button. So, I've got that out there, and then I've got a few HTTP files. These are in the Jinaga server repository, so everyone's got access to these on GitHub. And so I've pasted that replicator URL into .env.local. And then I've got a few HTTP files that are sans auth, so no authentication or authorization for these particular endpoints. So I want to get the sites in this particular replicator. So since there's no authorization, a Jinaga user is just something with a public key. With authentication turned on, then when you log in, you can actually use your real user, and it gives you a real public key that's just for you. And then, so here I'm going to get all of the sites, the blog sites from a particular creator, and list out their domains. So I have already set up a single site out there with the domain michaelperry13.net, because I've been testing and I got up to 13. So if I want to use feeds in order to read this information, the idea of feeds is that you pull enough information back to the client to be able to run this query locally. You don't pull back the result of the query like I just showed here with the read endpoint. And so I can hit this, not this one, let me start with this one. I can hit the /feeds endpoint with that same specification. And now this returns a collection of feed objects. So a feed, actually just a collection of strings. So a feed is identified by its hash. So here is the URL safe hash of that particular feed. And then I can do a get against the replicator URL /feeds /that hash. So here's the ATOB. And, or SOB. Looky reference. So if I get the feeds, now, or this particular feed, I'm going to get back a set of tuples. So these are the references, the fact references that show up inside of those tuples. So basically, this just gives me a stream of information that then if I were to fetch these facts, I would get enough evidence to run that specification myself. And it gives me back a bookmark. So right now we're up to 153. So you can see that it returned this information and then it stopped. So let me switch real quick to curl, and we can see here I'm doing the same thing. So I curl, here's my replicator URL, /feeds/8tob, and then I get back that JSON response with the bookmark 153, and then I stop. If I were to say question B equals 153, that means, okay, I've received this information, I've stored it, now give me more information. Has anything happened since then? And you get back an empty collection and the bookmark 153 saying, nope, nothing new. So what I want to be able to do is I want to be able to subscribe to this feed. I want the server to push information back to me. And so where I landed on that, let me make sure I get the syntax right. I use the -h to pass in an accept header. So let me go back to right here and -h. Pass in that accept header. I think I deleted something.
Michael, but so that
Yeah,
feed is
there we
giving
go.
me back the type and the hash.
Yes. So just the type and the hash. So if you already have that fact locally, then you're good. If you don't, then you can call load and retrieve the other details about it.
Okay.
So load takes a collection of references, reference being a hash and a type, and then it builds a graph. So it does the transitive closure, and it gives you back all of the predecessors and all of the fields. So that that second step makes it just a little bit more efficient. So you don't have to ask for individuals and walk up the graph yourself and add some latency to it. It's like, okay, here's what I need to know. Go. And then if you already know it, then you don't ask the question. So it limits what it pulls back. So what I'm doing at this point is I am adding the accept header. I'm looking for the type application/x Jinaga feed stream. So this is a custom. Is that technically a MIME type? We'll say MIME type. That might not be the correct use of that term, but that's a custom MIME type that the replicator understands. And so now if you ask for that, it will give you back the response. Oops. I wonder if the deployment hasn't worked. I might need to switch to a local demonstration. What I expected to see is that I get back the response, and then it keeps the connection open.
Okay.
So let's run this locally real quick, because I know that worked. And besides, you can see some interesting things with the local. Okay, so starting up the desktop Docker engine. So I'm going to start the Jinaga database in Postgres. So instructions for how to set your own database up are out there. So that's Replicator service. That's the multi-tenant database. This one right here is, this one right here is my typical Jinaga database. So we can look and see, show me the raw values there. So this is dev pw, and the app database is my application. That's all just default settings if you use this particular if you use the instructions to set up this this thing. So the instructions you will find at Jinaga server. So if you go to the README, it tells you how to set up the database. So just follow those instructions. Here's the secret password, app user, app pw, and it sets it all up. Okay, so then let me do an npm CI, make sure everything is installed, and then npm run. We can see we've got a few scripts out here. One of them is debug. So this runs a distributor using this little yeah, let me find the source for it. Oh, no, this is the distribution. It's the compiled code. It runs a replicator. There we go. And so the replicator uses, oh, this is using the replicators. Oh, okay, that's, yeah. That's different. Where's the debug code?
Was the multi-tenant one.
Yeah, that was the multi-tenant stuff. So, well, let me do an npm run build just to make sure we've got it. Npm run debug, and so this starts listening at localhost 8080, and we can open it in the browser, but that's not going to help us any. So now we should be able to change this URL to be http://localhost 8080/Jinaga. So with that replicator URL, let's go back and create sites. Well, first of all, let's get sites. Let's just see if there's already some stuff out there. So here's our local environment. Yep, that's all set. So send that off, and connection refused, localhost 8080. Interesting. I wonder, do I have something else listening at port 8080? Well, no, it's connection refused. There's nothing listening at port 80. But this one says that it is. Well, this is starting to look like more of the typical demo. Okay, good. I was a little bit worried that things were getting too easy. Okay. Why is this not working? Yeah, that's the same. Get sites. Connection refused. Okay. Just to try things out, let me go to another WSL window. Go to projects, Jinaga server. So here, npm run dev. Debug. Okay. So you said it's running on port 8080. Let me see. Open in browser. Yeah, can't get /. All right, so that means that there is something listening at port 8080. Why is it connection refused though? That is so weird. Okay. So I am going to shut down all of my VS Code windows and then start back up with Jinaga server. Here's my env local. Here's get sites. Use local and send. Still connection refused. Huh. Well, I could see that I can navigate to it. That is very strange. Well, let's see how much of this we can do with just curl. All right, so if I were to curl, well,
Restart VS Code.
just did that and colon whack host 80 / Jinaga / I'm gonna read, and so in order for me to do an HTTP post, I need to remember my curl syntax. Curl posts. So I do a -x, looks like a capital X, post, and then the data, I use a -d, so -d. Okay, so I've got all this data. How do we get this multi-line data pasted in here? I doubt this is going to work. Okay, I'm going to put slashes at the end of everything. Okay, let's see if that works. Oh yeah, and I need to send in the content type. So let me set the /h content type text plain, and then we paste in all that, and I don't think that made it in the right order. Okay.
Can we not ask curl to read it from a text file?
Oh yeah, that's right. Yeah, you can do that. Okay.
Remove all the backslash.
Okay, so let's take this. Let's create a new text file, and we will call this. So I am in projects Jinaga, so I'm just in the root folder of my Jinaga projects. So let's save this in projects Jinaga, and this is read sites .rs? No, txt. So I can cat read sites. There it is. Okay. All right. So now do I just stream it in? I think I do. So let me cat that into curl -x post -h will be content -type application or text plain. Yep, text plain.
There's an L too much.
Yeah, thank you, sir.
And now a P.
Oh wow, that's weird. Text /plain. Okay, and then we're going to do a now we're going to give it the URL. So that's going to be HTTP localhost. It is acting weird. 8080 slash, let's just start with read. Cannot post read. Oh, Jinaga slash Jinaga read. Okay. The content type should be, okay, yeah, there's the extra T. That is, what is wrong with my keyboard here? Post with the header content type text plain.
But that pipeline, is it going to work for curl like that? Because otherwise you need -D for the data.
I think it should. So it's saying to that it expected a string. Check the content type of the request. So it's not seeing the header for some reason. Yeah, post-h content type. Yeah, that is the correct syntax for that. Okay, the next attempt. Let's go to Postman. Something's definitely going on with my tools here. Right. So let's go. Let's just create a brand new collection. And demo gone wrong. Okay. Here's a new request. And get sites. So we are going to do a post to, yeah, here we have this working. There's all those exceptions that's been thrown. HTTP localhost 8080. And then we're going to do slash Jinaga slash read. And the body is going to be this text, raw text body. Send. Password authentication failed for app user. Interesting. Okay, so I think I might have started the wrong one. Let's see. This one here, the app user should be dev and dev pw. Database my application. I wonder if this one, improving UDB, if I was using this one for the last test here. Dev. No. Okay, let's just change the okay, I want to change the connection string it's using to access the database. So let's find, why does this timeline keep opening up? You stay closed. So this debug, where's the scripts? Here's the scripts. Debug script is using this debug.js. And so if I go to source, debug.ts, that's the source version of it. So here it's doing app and appdb. I wonder why I keep changing these things.
But there it's using another port, 5432.
Yeah, that's the Postgres port. So this is the Postgres connection string.
Yeah.
Yeah, so, okay. Well, one easy way to do that then is right here. let's set Jinaga Postgres equal to PostgreSQL // and now the username is actually the name dev, and then we have the password, so :dev pw, and then we have at localhost 5432, and then the name of the database / I believe it's called my application. Let's double check that. My application is the app database. Okay. All right, so I'm going to set that environment variable before I do the npm run dev debug. Okay, so now we've given it a correct connection string to the database, so now it's able to connect to the database, give me back an empty result set. Excellent. My goodness. So what was wrong with this guy? Why is he saying connection refused? He's also running in WSL, and well, this one's not running in WSL, but this is, I don't know, that might be part of it. At any rate, we have a server, and we have a way that we can ping the server. So there's how we ping the server. So now let's save that. Let's create a new collection, a new request. Where's my new request? Add request. Okay. So this is going to be save site. So I'm going to do a post to the same URL, 8080, but here Jinaga /write, and the body is raw text, and I'm going to give it some facts. So where are the facts that I want to give it? So create site. So here's my Michael L. Perry 13. Let's go ahead and start this one over at 1. Okay. So yeah, don't need that part. We're just going to post this to the right endpoint, and this should save that into my local replicator database. And so we see that it has done some stuff, did a thing. And now when I go back here, let's save that, and I go back to this one, and I read, I should get back michaelperry1.net. Okay. We are getting there. So now let's get some feeds. So create another request. Here we are going to post to, instead of the read endpoint, we're going to post to feeds. And this body is raw text, and it's the same as the read. It's just, what's the specification? And so this will give me back the collection of feeds for that particular specification. So now I've got the feed that answers the question. So let me first run this request. Call it get feed, and now this is a get, so I'm going to do http //localhost Jinaga /feeds, but then the feed URL, and so it's a get, no body, and so this streams back, or this retrieves the references since that last bookmark, which is now at 23. All right, save that. Let me also give this a better name so we can see what's going on. Okay, so that's get feeds. Here's get one feed. Now we've got this nice little button over here to grab some curl code that does the same thing. So I'll copy that, and I will go back here, and I'll paste that in. And so we are getting the feed from the local replicator. Now, if I were to add my header, something is really off. It's overwriting sometimes. Yeah, I don't trust my terminal here. Let me exit that terminal and start a new one. Okay. There's the curl command. Dash header. And now I'm going to say content, right, accept. This is the accept header. I'm telling the server, hey, this is what I want you to return. So accept application /x -jinaga -feed -stream. Okay, so now that's what I wanted to see. So it returned the first result, and then it kept the connection open. It didn't give me back the command prompt. So that is, so that's telling me the socket is still open. And in fact, we can see some extra stuff coming back from the server side here. We've got the initial response. That's what it sent here.
And so now if we make a successor of that block site fact, then it should automatically feed it.
Yep, but not a successor. What we're looking for are additional facts that would match this specification. So if we have an additional site, so not a successor of this site, then we'll see something show up. So we've got save sites. I'll change this to Michael Perry 2, and then so that we can see everything working in real time, I'll kind of squish that up. And then when I send that, if everything works well, we should get, get our response. Yes. Yeah. And then furthermore, the server is telling us that that it did some additional work. We saw some more stuff scroll by. Here are the connections to Postgres and the connection pool. I thought, yeah, here's an initial response. I thought I had another. Yeah, I thought I had another message that I wrote out to say that, hey, I've got some updates. But we can see that we got some updates. If I try to send that same fact again, nothing happens because it's seen that, oh, I've already received this. This isn't new information that I need to share with anybody. But if I were to change the fact, so let's go up to 3, then boom, and now I get that new fact here. So you can see it's bumping the bookmark every time, and keeping that socket open. So yeah, that is how I decided to stream the new information back to the client. I still need to work on the actual client side of this, but that is keeping things going.
It's nice. So no more polling now.
Correct. Yeah, there are Yeah, there are a few things that a few additional things about this that are kind of interesting. I don't think I've got a demo that would really show this. So yeah, so we can just kind of chat about this part of it. Um, yeah, so this is using um, it's using a modification of HTTP that is similar to, but not exactly the same as, server sent events. Um, so yeah, there's been a few different ideas around this kind of push technology that have floated around, and server sent events is the closest to what I need, but it's still not exactly right. And so in the community, I've found that you know, other organizations that are in this particular this particular use case, they end up doing something very similar to this, where they've got a custom content type, and then when the server sees that you want that content type, then it goes into this mode. And the response does not have a content length. Instead, it just sets the keep alive header. So it asks the client to keep the connection alive. So that is so basically. Yeah, what are some of the other things that have other options? So there's WebSockets, and in fact, the very first working iteration of Jinaga was built entirely on WebSockets. It didn't even have an HTTP endpoint. It just was WebSockets. And that was way too heavy. If I were to use WebSockets now, I would use them in this way, but and it wouldn't be nearly as resource intensive on the server, because a WebSocket basically is this. It's keeping a connection open to the server. But yeah, I was doing that for every push, every pull, everything. Mm. So I might actually implement a WebSockets version for some of the problems that this one still has. So WebSockets are bidirectional. So you open the socket, and then the client can push stuff to the server can push stuff to the client. This, since it's using a single HTTP request and then just keeping the response open, the client can't send any more information. So it's just to the client, just from the server. Mm-hmm. So yeah, this is the same way that server sent events works, but the difference is that server sent events has its own special format, and also has some pretty important restrictions. I'm not sure why they added those restrictions, but the format that it uses is that it sends back a packet with data colon and then a string of data, new line, and then you can have another element. I can't remember what the other one was, but yeah, data colon is usually the one that's used, and then two new lines to separate it from the next one. So so it's got a prescribed format, but then of course you can put whatever you want on that line. So I could put JSON on that line; it'd be just fine. So I could do that, except for the fact that server sent events does not support adding additional headers. So you use server sent events in the browser with an object called event stream. And I think it's called event source, but it's not related to event sourcing. So you create that browser, that object in JavaScript in the browser, and then it handles the protocol. But that object doesn't give you any way to add headers, so you can't add an authentication header or authorization header. And so what you do instead is that you allow cookies to flow through, and then you use a cookie on the server side. But but I'm not using cookies for authentication. I'm using the authorization header. So I don't want to use a different authorization mechanism. And so basically you would have to re-implement the client side yourself. And then if you're going to do that, it's best not to use the content type that means this is an event source. Instead, you use your own custom content type. And if you're going to do that, why use the data colon format? So that's what people do. So, yep, that is.
There is no
that's where that ended up.
100% solution for it right now.
No. And so WebSockets actually is probably a slightly better solution for one important reason. The client can't send anything back to the server while it's reading from the feed, and in fact that's it. I don't want the client to send anything new because it's got other feeds that it's using to learn about other things. It can open up multiple feeds and that'd be fine. The problem is that if the client can't send anything, it can't send a keep alive. It can't tell the server I'm still here. And so what I've done with this one is I've made the server close the connection after 5 minutes. Oh yeah, that's right. That's something that I didn't demonstrate. Let me switch
Because
back.
if you don't, you have no way to control how long it will be open otherwise.
Yes, and that could be a serious problem. Okay, so let's go back to...
Problem only in case of bugs, because if your application exits, you close the connection automatically.
Yep. So here we've been talking for more than 5 minutes, so I've got done. The server has closed the connection, although I've not tested this before. It looks like it didn't do a proper shutdown of the socket because the client's still hanging around. So let's simulate a client calling back and saying, okay, I have received up to bookmark 25. And so the server sends the initial response of nothing now, but let's keep talking. Excuse me. So if the client closes the connection, so I'll hit Control-C, boom, we can see the server says done. So the server recognizes a clean shutdown from the client and closes its connection. But as we see here, this done, the client didn't send the shutdown. Instead, the server timed out after 5 minutes, and so the idea for keeping the server nice and clean and not having too many resources open all the time is this just 5-minute shutdown. If the client is still interested, then they'll call back. And so that's a 5-minute keep alive, 5-minute heartbeat from the client. That's really the only way that the client can send more information to say I'm still here, is to actually make another connection. So that might be okay, that might not be, but still I need to fix this problem where after 5 minutes the server needs to send a fin back to the client. But apparently that's not happening. So I will work on that bug for sure. But yeah, if these were WebSockets, then I could send a keep alive request in either direction. So WebSockets might be the better choice here.
But so anyway, the connections would keep open on the server only in case of bugs in the application. If you open a feed and you forget to close it.
Yeah. So the server still needs to just close after some certain period of time. Now, if the client continues to send. Yeah. Okay. Yeah. So I see what you're saying. So if there's a bug in the application and the client hasn't crashed, but it's not interested in that feed anymore, it'll still ping that keep alive. Yeah. Yeah. And that could very easily happen in a Jinaga application. So we haven't talked about what the client code looks like, but it's basically what I'm envisioning is the j.watch is there's just going to be a different variation of that. So j.subscribe, and it looks exactly the same as watch. So you get your callback whenever things come back in, but subscribe is keeping that connection open. So I like that because that means that you can just write your app the way that you would normally write the app, and then you say, okay, in this case, I really want live feedback. I'm interacting with another user, so just change watch to subscribe, and you're good. Um, but but yeah, it's with a watch. What you really want to do is close the observer. So j.watch returns an observer, and you should call observer.close whenever you're finished with it. So it's easy to forget to do that in your view model. And if you forget to do that on watch, then you're just eating up some of the client memory. And so yeah, you still have this event hanging out there that anytime a new fact shows up on the client, it's going to ping that event, but that event isn't connected to a view anymore. So it's updating a view model, but there's no view looking at it. So you just have a memory leak. But if you forget to stop an observer on a subscribe, then the client will use that keep alive mechanism. So in this mechanism, every 5 minutes, it will try to make another connection and keep that connection open. Or in the WebSockets version, should we get there, it will send keep alives down that WebSocket. So in that case, you are doing damage to the server. You're using server resources where you don't need to. So yeah, I don't know how to truly protect against that. It's going to be an interesting one. Yeah, how do you differentiate between a bug in the program and just somebody staring at the screen for 10, 15 minutes? I don't know. So these are the things to work on next. We're making progress.
Yeah, but I don't see how you can detect the difference between the two.
Yeah. Yeah, I don't know. Yeah, so yeah, I will. I've definitely collected a bunch of bugs that I can work on fixing, and then I also want to make the client side code so that it participates in this protocol. So I'll do that for both .NET and for JavaScript. And in fact, there is a place in the Replicator as a Service portal that really needs this feature. Because something changes on the back end and you don't see it on the front end. This is when it's generating a secret, and so it's storing the secret in the Azure Key Vault, and then it's got to tell you, okay, here's the secret that I generated for you. But since that's all happening in the back end, then you have to refresh the page in order to see that your secret was generated. So I'll use use this mechanism to fix that. And I will code it up correctly so that it stops subscribing as soon as it's got the secret. But yeah, there's no guarantee that everybody would code it up correctly.
Well, you could add a limit on the server. If so many feeds.
Yeah.
We limit to a number of feeds.
Yeah. Yeah, that's true.
Or if the number of feeds keeps going up
Mhm.
for an application.
Yeah. Yeah, and that would be at a per replicator uh, basis. So yeah, so that way I can tell the application developer, hey, this replicator is is maxing out. So then there are probably the developer of the application. They can say, oh, okay, here's the reason. Maybe I can even in that debug stream that we were talking about, um, have some details that will help them find it.
Or better,
Yeah.
once you go above a number of feeds, slow down the feeds so that doesn't crash the applications, but customers of the developer will start complaining that the application is slow. And so the developer will say, hey, there is something wrong. Will say, Michael, no, you have too many feeds open. That way you don't break the application, you don't bring the developer in trouble. The customers can keep working, it only goes a little bit slower.
Yeah. Yeah. Yeah, that makes sense. Yeah, and so that could be a throttle on the establishment of a new feed. So so yeah, then it'll time out a feed, you know, yeah, close that connection, and then if the application is behaving badly, then it'll try to create a new feed, and it'll just get a little bit of a delay before it's able to establish it.
Throttling on the creation of a new feed, or just the time between you send a new fact in, it gets a new fact, and the time that you get warned about the new fact, so that there is a delay there.
Yeah.
Now, customers might not see that immediately.
Yeah, and that still keeps the socket open, so the resources are being used even while you're throttling. Yeah, versus throttling on the creation of a new feed means that for that duration of the throttle, there's not a connection. Well, no, there still is a connection being used. Yeah, because you're saying, all right, connect, and then wait for, okay, now here's the first result. Yeah, that doesn't solve the problem.
Well, it's just a matter of informing
Yeah.
the developer
Yeah.
without really crashing its application.
Yeah. Okay.
But then what's the limit?
Yeah.
You might have a very small application, a very big application.
Very true.
Yeah.
Okay. Yep. So next
Well,
week we'll see this work a little bit better. I'll show you a little bit of the behind the scenes, how this actually works. Because actually the mathematics behind this are just they make me so happy. But
okay.
I'll show you that next week.
I'm interested to hear that. I'm gonna continue to dig deeper into OAuth, make the drawing that I wanted to make about the implementation in Jinaga, in the Replicator, and then read chapter 4.
Very good.
Yeah, so many things I'm behind, so work enough to do. Okay, Michael, see you next Thursday then.
Yes, indeed. See you then.
Okay.
Thanks, Jan.
Thank you very much. Bye-bye.
Bye.